Gravity is a fundamental force of nature that governs the behavior of matter and energy in the universe. It is the force that attracts two objects with mass towards each other, and its strength is proportional to the mass of the objects and the distance between them. The concept of gravity was first introduced by Sir Isaac Newton in the 17th century, and it was later explained by Albert Einstein's theory of general relativity in the early 20th century. According to this theory, gravity is not a force, but rather a curvature of spacetime caused by the presence of mass or energy. In other words, gravity is the result of the distortion of the fabric of the universe by massive objects. According to popular legend, Newton was sitting under an apple tree when an apple fell on his head, inspiring him to consider the nature of the force that caused the apple to fall towards the earth. While the apple tree story is likely a myth, it is true that Newton was observing the motion of objects and trying to understand the force that governs their movement. Newton's breakthrough came when he realized that the same force that causes objects to fall towards the Earth also governs the motion of planets around the Sun. He formulated the law of universal gravitation, which states that every object in the universe attracts every other object with a force that is proportional to the product of their masses and inversely proportional to the square of the distance between them. This law provided a quantitative understanding of gravity and allowed scientists to make accurate predictions about the motion of celestial bodies. Newton's work on gravity was a major milestone in the development of modern physics and laid the groundwork for subsequent discoveries in the field. It was later refined and expanded upon by Albert Einstein's theory of general relativity, which provides a more complete understanding of the nature of gravity. Gravity plays a crucial role in many physical phenomena, such as the motion of planets around the Sun, the tides on Earth, and the formation of galaxies. It is also responsible for keeping our feet on the ground and giving objects weight. Gravity is a fundamental force of nature that is intimately woven into the fabric of the universe. As such, it cannot be broken or turned off like a switch. However, there are ways to mitigate or counteract the effects of gravity in certain situations. One way to counteract gravity is through the use of spacecraft and rockets. By accelerating a spacecraft to a sufficient speed, it can enter into orbit around a planet or moon, effectively counteracting the pull of gravity and allowing it to remain in space. Similarly, by accelerating a spacecraft to escape velocity, it can leave the gravitational pull of a planet entirely and travel through space. Another way to counteract gravity is through the use of buoyancy. Objects that are less dense than the medium they are in, such as a helium balloon in air or a ship in water, experience an upward force that counteracts the force of gravity pulling them down. This principle is used in hot air balloons and blimps to lift objects into the air. In theory, it may be possible to manipulate gravity through the use of advanced technologies and exotic forms of matter, such as negative mass or exotic matter. However, such technologies are purely speculative and are not currently feasible with our current understanding of physics. In a zero-gravity environment, such as on the International Space Station or during a parabolic flight, people experience a feeling of weightlessness. This feeling is often described as similar to floating or being suspended in midair. Without the force of gravity pulling down on the body, astronauts and other people in a zero-gravity environment can move around freely and perform tasks that would be difficult or impossible on Earth. They may feel a sense of disorientation or space sickness, initially as their bodies adjust to the lack of gravity, but this usually subsides after a few hours. In addition to the physical sensations of weightlessness, people in zero gravity may also experience psychological effects such as a heightened sense of awe and wonder at the beauty and vastness of space. Many astronauts report feeling a profound sense of connection to the Earth and the universe as a whole when they see it from a distance. Overall, the feeling of zero gravity is a unique and awe-inspiring experience that can provide valuable insights into the nature of the universe and our place within it.